series. Our focus is on probability and statistics 2, that is paper number 6, June 2021, variant 1. Let's look at the first question. First question is about accidents at two factories occur randomly and independently. On average, the number of accidents per month are 3.1 and 1.7. So this is a question of Poisson distribution. First of all, you can say the first factory A follows a Poisson distribution with 3.1 and B follows a Poisson distribution with 1.7. And this data is actually for per month. Find the probability that the total number of accidents in the two factories during a 2-month period. So therefore, total, first of all, so 3.1 plus 1.7, that is 3.8, 4.8. This is per month. So therefore, 2 multiplied by 4.8, that is 9.6. So let W follow a normal distribution, no, Poisson distribution with 9.6. And it says it's more than 3. Probability W is greater than 3. What is the next integer? Probability W is greater than or equal to 4, which is 1 minus probability X is less than or equal to 3, which is 1 minus e raised to power of minus lambda 1 plus lambda square over 2 factorial, lambda cube over 3 factorial. It's between you and your calculator. Take care of the accuracy. Question number 2. Now the question says the times taken by students to complete a test has a normal distribution such and such. Find the probability that the mean time taken to complete the test by a random sample of 40 students is less than 123 minutes. So the first part, it's about sampling distribution. Part B, it's about central limit theorem. So it's calculation as well as reasoning. So you would say X follows a normal distribution 125, 36. Since it's about sample mean, so X bar follows a normal distribution, the mean remains as it is, the variance is divided by 40. And then probability X bar is lesser than 123. Probability Z is lesser than 123 minus 125 divided by 36 over 40 square root. Probability Z is lesser than 2.108, and which rule is this? This is direct reading, and what you get is that 0.0175 or 176. So these are the answers correct to 3 significant figures. That's the first part. Explain whether it was necessary to use CLT. The answer is no, it's not necessary. Why? Because the distribution was already normally distributed. So if it's already normally distributed, why should I make it approximately normal? Central limit theorem is making it approximately normal distribution when sample is large, when n is greater than or equal to 30. When it's already normal, irrespective of sample is large or not, you don't need anything else. Let's move to question number 3. It says probability density function. That means it's a concept of CRV. The graph of a PDF of a random variable is symmetrical about the line x is equals to 4. We don't have the graph. Neither we need to draw it. Yes, a little help from a number line will be highly appreciated. So it is symmetric about the line x equals to 4. and somewhere here is 5, somewhere here is 3. Lesser than 5 is 20 over 27. So therefore, if I draw this, so lesser than 5 in this direction, that is 20 over 27. Therefore, greater than this thing, the green line, that would be 7 over 27. So 20 plus 7 is 27. Okay. So this is the number 5. What else is there? Find the probability that x lies between 3 and 5. In other words, this 3, left of this 3, this should also be 7 over 27. Got the idea? Why? Because 3 is 1 unit lesser than 4. 5 is 1 unit greater than 4. So if this is greater is 7 over 27, lesser should also be 7 over 27 because of symmetry. And now they are asking something in between. So this is 7 over 27, this is 7 over 27, therefore this thing would be 1 minus 7 over 27 plus 7 over 27. This is basic number line calculation, which is 1 minus 14. So 1 minus 14 over 27, which comes out to be 13 over 27. So that is the working for this particular part. Just a simple working. Question number 4. What does it say? Question number 4 says that we have some data, 100 randomly chosen adults, each throw a ball once. The length of each throw is recorded. The length is summarized below. So this is the data that we have. Calculate a 94% confidence interval for the population mean. So another question of confidence interval for population mean. When I say another question, I was referring to the previous past paper that was of February-March 2021. First of all, 94% confidence interval. That means it's 94% over here, 3% at the corner, 3% at the corner. Therefore, the z value would be for 97%. So let me choose another marker. This is too thin. So the z value would be 1.881 or 1.882. Okay, that's correct. Now, what else is there? This is in terms of L. So L bar is sigma L over N, which is 3820 divided by 100, which is 38.20. They are not asking us for any unbiased estimate. So if they would have, unbiased estimate of population mean is the same thing as sample mean. Similarly, sample variance, that is sigma L square over N minus L bar square, that is 182 200 over 100 minus 38.20 square, whatever this answer comes out to be. And unbiased estimate of population mean, it's N over N minus 1 sample mean. I prefer to use this calculation. That is 100 over 99 into this value. And after calculation, what I get is 366.424. 366.424. In the previous paper also, I showed the formula, that is this particular one, that you can also use this formula directly. Coming back to this question, what else do we need? We need standard deviation, unbiased estimate, that would be square root of 366.424, whatever this comes out to be. X bar plus minus z sigma over root n. X bar is 38.2 plus minus 1.881. Sigma is square root of 366.424 divided by root of 100, and then you end up with two answers. One answer is 34.6, the other one is 41.8, rounded off to 3 significant figures. So question number 4 was also very basic. Question number 5. What is question number 5 all about? Question number 5 looks like poison, a binomial turning into poison, and yes, again poison. So basically this is about Poisson distribution. It says use a suitable approximating distribution. Now make a habit of always write the original data, the original distribution. Original is binomial. 10,000 is your number of trials. 1 over 75,000 is your probability of success. NP is 10,000 into 1 over 75,000. So let me grab the calculator. That is 2 over 25. So this is 5 2s are 5 25s. So 2 over 25, I'm writing it like this. Actually, it's not 25, it's 15. 2 over 15, that is this thing. Since n is greater than or equal to 50 and np is lesser than 5, therefore x follows a Poisson distribution with 2 over 15. You can convert it into decimals also. At least 1. Probability x is greater than or equal to 1, which is 1 minus probability x is equals to 0, which is 1 minus e raised to power of negative 2 over 15, and then you get the answer. This is the first part. Second part. In a random sample of n people where n is large. Now, if you have done a lot of topical questions, this question has come many times. But now what the examiner does is that they specify n is large. What it means is that still write this thing as binomial 1 over 75,000, and expectation of x is np, that is n over 75,000. So let me write this thing over here. This is expectation, because expectation is lambda, and you can convert it into a Poisson distribution. So x follows a Poisson distribution with n over 75,000. So that is the first thing that you can do. If they would not have written this, then it's not worthwhile doing the approximation. You can just do it directly by binomial. So x follows a Poisson distribution with such and such. Probability that no one has genetic order. So probability x is equals to 0 is e raised to power of minus lambda, which is n over 75,000. This probability n over 75,000 is more than 0.9. It's greater than 0.9. So now pure maths P3 comes into action. Take log, natural log of both sides. ln e raised to power of minus n over 75,000 is greater than ln of 0.9 minus n over 75,000 ln of e is greater than ln of 0.9. Now remember, ln of any number between 0 and 1 will be negative. So there will be a negative sign over here. That's first thing. There is already a negative sign over here, and we all know that ln of e comes out to be 1. So therefore, when you do the calculation, this comes out to be n after the calculation, after the multiplication and anything. So n over 75,000 with a negative sign. So this negative would cancel. N is greater than the answer. So let me grab the calculator. That is ln of 0.9. So first of all, I'm writing 0.9. I'm taking natural log. I'm multiplying it with 75,000. That comes out to be 7902.03. 7902.03. Pick the next integer. Therefore, n is 7903. So that is the working for this particular part. So let me double check the answer. That's perfectly right. And this is all good. The inequality has not flipped, my bad. The inequality has to flip. So therefore, this is like this. N is lesser than this thing. Therefore, in this direction, the first integer that comes is 7902. So make sure that you flip the inequality. I talked about it, but I forgot. But then I double check. So the key to success is double check always. So that is the first thing. Question number 6. Now this is again a CRV question. The question says the probability density function is given by such and such, where k is a constant. State the value of Ex. Show that variance of x is 9/5. And it's for 6 marks. Now the question is, should we find the value of k? Answer is yes. So first of all, you would say, let's integrate the function between the limit 0 and 6. That is 6x minus x squared dx. Don't forget the k, and that should equal to 1, because this is DRV. Total area under graph is this. So k, 6x squared over 2 minus x cubed over 3 between the limit 0 and 6 equals to 1. You would simplify and do the calculation. K comes out to be 1/36. That's the first thing. Second thing, let's calculate expectation of x square. I'm not calculating expectation of x because that's obvious. I'll just show you in a short while. That is a to b x square fx dx. Limits are 0 to 6 x square, and the function is 6x minus x square. So therefore this is 0 to 6, 6x cubed minus x power 4. You still have to integrate it. That is 6x power 4 over 4 minus x power 5 over 5 between the limits 0 and 6, and you will get a particular answer. Now why does it say state the value of expectation of x? Remember, any graph with symmetry, the expectation of x will be the mid value of limits. Remember this rule. When you have this graph, so I'm drawing this, that is 6x minus x square. So of course knowledge of P1 is assumed irrespective of the value of k. So the function is k, and this is x 6 minus x. This is x 6 minus x. So when you draw this graph, first of all, it's upside down. So that is the first thing, that this graph is like this. And don't go on my drawing. This is 0, this is 6, that the mid value of the limits is 3. So therefore expectation of x is equals to 3. What is variance of x? That is expectation of x square minus square of expectation of x. That is whatever the value of expectation of x square is minus 3 square, and then you end up with the answer for variance of x. And they have already given us the answer, and this is just one part working. And question number 7. What is question number 7 all about? So question number 7 is the masses in kilograms of large and small sacks of flour have a normal distribution such and such. Large follows normal distribution 55,3 square. Small follows normal distribution 27,2.5 square. So let me write this on the next page also. 55, 27, 9 and 2.5 square. 55, 27, 9 and 2.5 square. Bracket close, bracket close. This is large, normal, and this is normal and small. And then it says some sacks are loaded onto a board. The maximum load is 340 kg. Find the probability that the board can safely carry 3 randomly large sacks and 6 small. So x is L1 plus L2 plus L3. Therefore x follows a normal distribution 3 times 55 and 3 times 3 square. Y is 6 small, S1 plus S2 all the way till S6. Y follows a normal distribution 6 times 27 and 6 times 2.5 square. W is the total. So therefore W follows a normal distribution. Let's do some highlighting. So therefore this is green. So first of all orange. This one will be added to this one. That goes over here. And then the green. This one will be added to this one, and that will go over here. So when you add it all up in the first part, this comes out to be 327 and this comes out to be 64.5. It says safely carry maximum load, it should be lesser than this. So probability W is lesser than 340 and probability Z is lesser than 340 minus 327 divided by square root of 64.5, and I leave it over here. Knowledge of S1 is assumed. You change it into the Z value, you read the table and so on. Next part. Find the probability that the mass of a randomly chosen large sack is greater than total mass of two randomly chosen small sack. So let M be S1 plus S2. M follows a normal distribution, 2 randomly small, that is 27, 27, that is 54, and 2.5 square is 6.25 plus 6.25. Now large is greater than S1 plus S2, which is M. L minus M is greater than 0. Let me denote this thing as R. So R follows a normal distribution. The means are subtracted. So let me go back over here. This is 55, this is 54, this time it's subtraction. So therefore this comes out to be 55 and this is 54, that comes out to be -1. And the variances are added. So this is the variance, actually this is 9 and 6.25, 6.25, that's 12.25 plus 9, that is 21.25. So this highlighting is over here, this highlighting is over here, so that is 21.5. And now what's the calculation? Probability R is greater than 0, probability Z is greater than 0 minus -1 divided by square root of 21.5, and then knowledge of S1 is assumed. Now question number 8 looks like the last question. And this is, at a certain large school, it was found that the proportion of students not wearing correct uniform was 0.15. So this looks like binomial to me. The school sent a letter to parents asking them to ensure that the children wear the correct uniform. So this looks like an upper tail test. So H0, P is 0.15, H1, the objective is that more students should wear not wearing correct uniform. So probability is decrease. So they should be wearing correct uniform. So incorrect uniform should go down. And X follows a binomial distribution. How many people are there? Sample of 50. Probability of success is 0.15. This is 5% significance level. Use a binomial distribution, this and that, and 4 students state the conclusion and so on. So it's a combination, it's binomial, and it's about hypothesis test as well as about type 1 and type 2 error. First part is about reasoning. The reasoning is a random sample of students in grade 12 should be used for this test. Why this would not be appropriate? Because this is a biased sample and give more info. Not other grades were not included. Other students of different grades were excluded. So that's what makes the sample as biased. Use a binomial distribution to find the probability of type 1 error. So now this is a concept of doing the calculation. That is, you start with a lower tail value, probability X is equals to 0. and you do the calculation. That is 50C0, success raised to power of 0, failure raised to power of 50. Keep on increasing. Probability x is equals to 1, probability x is equals to 2, probability x is equals to 3, and make sure all the probabilities that you calculate convert it into percentage so that it's easier to work with. When you do the calculation, what happens is that probability x is lesser than or equal to 3 comes out to be 4.61%, whereas probability x is lesser than or equal to 4, that comes out to be 11.2%. So you want the sum of the probabilities to be lesser than the significance level, which is 5%. So therefore the critical region is 0, 1, 2, 3. So therefore x is less than or equal to 3. This is the critical region, and probability of type 1 error, which is the true significance level of the test, that is 4.61%. So that's how this working is done. Now, what else is there? The critical region is 0, 1, 2, 3. So let me label it. This is 0, this is 1, this is 2, this is 3. And in fact, 4 students were not wearing the correct uniform, state the conclusion of the test. This is 4. So 4 is not part of critical region. Therefore, H0 is not rejected. In other words, H0 is accepted. That means there is no evidence. Insufficient is the right word. Insufficient evidence that the probability or the proportion of students not wearing correct uniform has decreased. So whatever that we were looking for, that probability, that 15% probability has not decreased because it's not part of the critical region. If for example, there were 3 students, we would say yes, there is sufficient evidence. 2 students, yes, the latter had an effect. 1 student's perfect is 0, that is the best. So the thing is, insufficient evidence that the students of not wearing the correct uniform has decreased, so there is no sufficient evidence for that. State with the reason which of the errors type 1, type 2 might have been made. A similar question was asked in February paper. Remember, if your value lies in critical region, type 1 error. Your value lies in acceptance region, type 2 error. So this value 4 is in the acceptance region, so therefore type 2 error might have been made. That is the maximum logic that they asked for. So that completes June and May 2021, the first variant, which is 61. Take care.